All right, hey there. Thanks for tuning in. Go ahead and grab your notebooks if you have not already. I'm actually giving this a second go. I recorded an entire 11-minute video only to find out that my microphone wasn't on, so I'm going to do it all again. I thought maybe you'd get a kick out of that. Title the top of your notebook, Solving Exponential Equations. Using common bases. This is one of two ways to solve exponential equations. This is a really nice way to do it. It's going to be the easier way. The problem is it just doesn't always work. You can't always get common bases. The other way is going to be logarithms, which we will learn, I believe, next week. So this whole process begins with what's called the common basis property. And I think once I write this down, you're going to actually feel like this looks familiar because we talked about it one day in class. There was a homework problem that was kind of similar to this. And what the common basis property says is that if you have x to the a equals x to the b, so we're talking about an exponential where both of the bases are the same, then what we can do is we can set the exponents equal and we can go from there. So the trick of it is learning, all right, how do we get them to have common bases? Because typically the problems will not. For example, let's say we have 2 to the x equals 8 to the 2x plus 1 power. This is where I actually need you to put your pencils down. Just listen for a second. I do this year after year, and I'm going to tell you there's one huge misconception that people think they do to get common bases. And once they get this misconception out of their heads, it starts to click. So let's talk about that right away. Put your pencils down, don't copy it, just watch. So what they do is they know that 2 to the third is equal to 8. And so what they think is, okay, well, I'm going to raise both sides to the third power, because if I raise both sides to the third power, then maybe I can get that 2 to become an 8. And we also need to remember this property that says that if we have x to the a and we raise it to the b power, that the base stays the same and it's to the a times b power. So let's apply all of that and let's see if cubing both sides has the desired outcome that we want. What I would do then is I would make base 2 stay the same and I would multiply my exponents. And over here, base 8 stays the same and we would multiply the exponents. So take a look. Did it do it? Did we get it to be the same base? And the answer is no. Because what I think you need to understand about this, I'm going to get rid of this, now you're going to get your pencil, is we don't get common bases by cubing both sides, squaring both sides. The way we get common bases is we are going to take the 8 and we're going to replace it with 2 cubed. We're going to use substitution and it's going to look like this. This side is still going to be 2 to the x, but like I said, we're going to take out the 8 and replace it with an equivalent expression, 2 to the third, and it's raised to the 2x plus 1 power. So I get 2 to the x equals base 2, and we multiply the 3 and the 2x plus 1. And so now that I've got the same base, now I can go ahead and I can set my bases equal. And I don't know if this is too much of a jump, but I'm going to go ahead and distribute the 3 when I set my equations equal to each other. And so let's just do a quick little math here. Minus 6x equals 3. X equals negative 3/5. And we have this nice, easy little linear equation to solve. So you're going to get to your homework, get the answer, look at the bottom, see if you can find it in the answer scrambled. If you can't, honestly, I think a lot of times people make mistakes with the distributing and just the little mistakes with solving. So just look over, see if you can find it. All right, next example. Example 2. So I'm going to give one that's kind of similar. This might even be a good part for you to copy the problem down. Hit pause on the video, okay? Hit pause, see if you can work through it on your own and do the things that we just talked about, okay? And then you can go back and you can, kind of watch me do it and see if you get the same answer. Or feel free, if you don't really get it, stick with me. I'll walk you through step by step. When I look at 9 and 3, the relationship that sticks out in my head is that if I take 3 squared, I'm going to get 9. Again, we are not going to square both sides. It's not going to change the base 3. So instead, we're going to take the 9 and we're going to replace it with 3 squared. We get common bases by using substitution. and this side's going to stay 3 to the 6x. And so when we take out the 9, we're going to change it to be 3 squared. And so now we've got base 3 to the 4x minus 2 power. Again, I am distributing, and that equals 3 to the 6x. Now I got same bases, so I can set my exponents equal to each other. Let's go ahead and start solving this little linear equation. And I divide both sides by 2, and I get x equals -1. So hopefully you got that question right. Okay, you check it at the answer scrambled. Off we go. Let's look at something that's a little bit more to it. Okay, 2 times 1/7 to the x plus 3 power equals 98. So what happens is people start spinning their wheels because they can't figure out how to make the 98 become a base 7. And the answer to that is you can't make 98 be base 7. Because what we need to know is that in this case, I have an initial value. In my other problems, I did not have an initial value. You will never see the 1 if 1 is your initial value. So what I'm going to do is I'm going to start by dividing by 2 by both sides. In fact, I'm going to make you a note. Divide the initial, I might have still spelled that wrong, initial value first, okay? I'm making a note. It's one of those things where we get it in the notes and then we go to the homework and we forget that I said it. Divide the initial value first. So what I actually get is 1/7 to the x plus 3 power is equal to 49. That looks more like it because now I can see a connection between 7 and 49. So a couple things I'm going to use. I'm going to choose to get base 7. It is possible for you to get common base 1/7. There are multiple ways to do these problems. Just please be aware of that. I'm going to get base 7. So I know that 1/7 could be rewritten as 7 to the -1 power. I also know that 49 could be rewritten as 4 squared. So you're going to find with these problems that sometimes it just takes a little bit of cleverness with trying to figure out how to get the base to be the same. It's almost like a little puzzle rather than so much follow the same steps over and over. And this is equal to, I'm going to change the 49 into 7 squared. And so there, I took the 1/7 and made it 7 to the -1. I took the 49 and made it 7 squared. On we go. I'm going to make it base 7 to the -x minus 3. Again, I'm distributing, equals 7 squared. And I got base 7. Set your exponents equal to each other. Add 3 to both sides. I get -x equals 5. Divide both sides by -1. X equals -5. You could plug it back in on a progress check to see if you did it right, or on your homework, I've got answer scrambled for you. All right, so last problem. You're going to see a couple that look like this towards the end of your homework, and you're going to see more that look like this on Tuesday's homework. And so what you're going to see is maybe we have something like this, where we've got 2 separate bases, or maybe we have a quotient of 2 bases. You're going to see that towards the end of your homework. Sometimes they all have common bases, sometimes they don't. But in this case, one thing I notice is that I have a common base of 6. So the first thing is we can't have 2 base 6's over here and set it equal to 1 base 6 over here. And so we need to use an exponent property that when we have x to the a times x to the b, the base stays the same and we add our exponents. All right, so that's what I'm going to use. First, just so I don't lose people, I do want you to know that we're going to multiply our exponents, and this is really 6 to the 2x, this is 6 to the 3rd, and this is 6. We can go ahead right now if we want, and maybe we could multiply it and make it 4x minus 4. So again, using that property I just talked about, base 6 stays the same, and we add our exponents. What's our exponent property when we divide? Do you remember that? If we take x to the a and we divide by x to the b, it's x to the a minus b. Just a little heads up, you might see that too. But now we got bases the same, so this is usually the part where it's downhill because we're just solving an ICZ equation. 3 equals 2x minus 4. 7 equals 2x. I divide both sides by 2. I get x equals 7/2. Okay? So that wraps it up for the examples, but I want you to stay tuned here. I want to talk about a couple things. In fact, this is how I'm going to know that you watched the video notes. So Monday's homework today. Monday, you're going to do page 9. And I actually only want you to do page 9. When you're done with page 9, go do something else. Do another subject. Go do something else. I want you to know, though, there's kind of like a typo. You need to add x equals 12 to the answers scrambled. You're going to get x equals 12 twice, but it's not in the answer scrambled twice. So I want you to add x equals 12 to the answer scrambled. That's how I'm going to know you watched the video, because you won't be texting me asking me if it's okay that you got x equals 12 twice. Second thing, you are going to text me the answers for number 11 and number 12. They're not in the bottom, they're not in the answer scrambled at the bottom of the page. Text me so that I know you're really getting it. I'll give you the thumbs up if you get it correctly, and we'll go from there. Now, this is important. Tuesday's homework is going to be page 10. And I want you to save page 10 until Tuesday. And here's my reasoning why. I don't want you doing it. So what's going to happen is you're going to find that you're going to get in the rhythm. You're going to start getting really good at it. And you're going to be like, oh, I got it. I'm going to do page 10. I want you to stop and not do page 10 because of the momentum that you're building. I want you to take a break, think about something else, give yourself almost a little bit of time overnight to almost forget it a little bit. Then I want you to come back on Tuesday, see if you remember the concept. Some of the problems are going to be a little bit trickier, and go from there. So split it up Monday and Tuesday, and that's it. So I'll have another video ready for you on Wednesday, and we'll start talking about a logarithm. Bye, good luck. Let me know if you have any questions.